This is the K-12 Engineering Education Podcast for October 16th, 2017. Can you program the game 20 questions on the computer? My guest today told me about one of her middle school students who did. I'm Pios Wong, and for this episode, I met with Julia Lamorelle at a coffee shop here in Austin, Texas. Julia is one of the co-founders of Kiwi Compute, a new education business based here in Austin that teaches kids how to program in Python, a major text-based programming language. Hear all about it next. Thank you so much for being on the podcast today.
Yeah, no problem. I'm excited to be here.
Yeah, I'm excited to have you here.
Yeah.
Because you've got a unique experience, I think. You've started an education venture here in Austin, Texas.
Yep.
And I've met you before. In fact, I saw you do your business pitch here in Austin a few days ago.
Yeah.
But I think a lot of people listening may not know who you are or what you do. Can you introduce yourself?
Yeah, so my name is Julia Lamorelle, and I'm the co-founder and CEO of Kiwi Compute. And basically what we do is we work with middle schoolers and teach them Python, which is a programming language, backend. And for me, it's really important to teach them to be confident learners. So teaching them through coding is really great because it builds their confidence. They're excited to continue learning. And typically we partner with after-school programs. We go during the day to schools. We teach private lessons. And for me, I just want every kid to be exposed to coding in some capacity.
Cool. Now, so you are a business.
Yes.
But you have an education focus.
Yes.
Tell me about the target audience, or who are you serving?
Sure. So I want every kid to learn to code, which means that is from every background, every demographic. And I think it's really important that kids that are in low-income areas learn to code because, you know, for them, it gives them a way to determine their own path because you can learn coding from anywhere. There are so many free tools out there that they can learn programming from their computer, at the library, at school, and then really determine their own path. They can go to, you know, ACC and continue learning. They can
community college here.
Yes. Yeah. So they can go to a community college and continue that learning. They can even go straight into a job if they're really good. And sometimes for kids, that's the best option, which I think is great to give them more choice.
Yeah. What age group are you looking to serve?
Yeah. So we work mostly with middle schoolers. I've gotten before feedback that that's a really interesting age to choose and that, you know, oh, middle schoolers can't learn to code. And that is so wrong.
People say that?
They do, yeah. They're like, oh, are you sure that because we're teaching them how to write code. And so they're writing Python. And there's a lot of block coding out there, which is the drag and drop. And
the pictorial or visual method. Okay.
Yeah, so Scratch, Hour of Code. And those are really great tools to teach kids to code or get interested. But then they need to move on to actually writing code. And most people introduce that in high school. Mm-hmm. So that's where like AP computer science and things like that. But the challenge with that is that middle schoolers, that age is when kids lose interest in computer science. And so by the time they get to high school, half the people aren't even interested anymore. So you have to reach them at a younger age, get them excited so that when they're in high school, they want to continue.
So when you were creating this business or this program, you saw that there was this gap. There's evidence for this.
Yes.
Okay.
Yeah. And middle school is a really tough age. They're very awkward, and they're very quirky and just, it's a tough age. And so it's often overlooked. And so people either focus at a younger age or at an older age. But middle school is often skipped a little bit.
Okay. And so you explained why computer science is important for everyone. You explained why you're focusing on middle school.
Yep.
Then you also talked about how you teach specifically Python, which is that text-based, you said back-end language. What's a back-end language?
So to make it very simple, front end is what you visually see on the computer, and then back end is what's running the actual website or program. I mean,
so it's doing stuff. It's not just the colors and things. Okay.
Yeah.
And so you're teaching kids Python, which helps control all of these inner workings of the program.
Yeah.
Okay.
And just for reference, Python is used in Snapchat. It's used in YouTube. It's one of the top 3 languages that tech companies look for today. And we don't necessarily tell our kids that because I don't think they really care about getting a job right away at Dell or wherever. They're more focused on, Snapchat, that's really awesome. Yeah. But for Python, we picked it because syntax-wise, it's one of the easier languages to start with. A lot of the kids we work with don't really know how to type very well. And so you need to start with the most basic language possible. And you can do a lot of really cool stuff with Python pretty quickly. Like if you teach them the basics, you can do a lot with them. Like I've had kids build their own calculators and build, really cool projects with Python after just a few weeks. And that's very empowering to them, but it's also challenging them, and there's different levels. So I can, push them if they get it really quickly, and they can go off and build really cool things.
So it sounds like even though Python might have a little bit simpler syntax, the complexity can be, it can be as difficult as you want it to be.
Yeah, exactly. And, sometimes kids do get bogged down by the little things in programming. And so if you can start with a language that is a little easier to understand, then you can add in more complexities over time. And the great thing with programming is that just like Spanish or Italian or French, when you know one, you can move to another fairly quickly because the concepts are similar. And so if they learn Python, they can move a lot more quickly to a front-end language or to a different language if that's what they want to do.
Do you see that? Do you see some of the kids in your program being, hey, I want to learn C++ or I want to learn JavaScript or something like that?
So I've worked with kids that have actually, it's the other way around. So they started with a different language and they came to Python. Yeah. Or they came from scratch or hour of code, and then Python is the first time they're writing a language. I've had some girls that I've worked with in private lessons start asking what's the best way to hack something? Like, oh my gosh, why are you asking that?
You gotta go, what do they want to do?
Yeah. We talked about what is a good hacker versus a bad hacker.
That's cool. So you're teaching computer literacy in a way.
Yeah. And I mean,
literacy.
It's good that they're asking those things because it means that they're curious, right? And middle schoolers are very curious. They want to know, what is a white hacker and what does it mean to do this? And so I find that good that they want to pursue it more and are interested in looking things up on their own and Googling things and solving problems. It's great. It's really good.
Going back to Python, one of the things that I've noticed and I've heard from other people is that, it can be a little easier to program in it, but that setting it up in the first place could be difficult possibly. And what I mean by that is for people who may not have set up Python before, maybe they have to install a bunch of software, get some libraries going in there, start working in Unix commands or whatever.
Yes.
How does Kiwi Compute streamline that process of just getting the Python environment set up, and how could other schools streamline that process?
That is a really great question. So when I teach private lessons, I walk through the setup with them, and it takes a little bit of time, but I think it's important to show them that and to have someone there to guide them through it. For our classes, though, we actually have an online browser that we use. So it runs Python online, and that way you don't have to download anything, because what we found is downloading Python, dealing with a text editor, it really confuses kids, and you have to teach them all these other pieces to even run the code. And so we wanted to make it as easy for them as possible to just type code in, run it, and see what comes out. So we actually created, if you go to app.kiwicompute.com, you can run any code online and see it from any computer.
And that'll be up. I can put a link to that in this episode.
All right. It's up. It's also on our website as a tab. And so that really helps us because kids can, we can go into a nonprofit and be teaching, and kids can save their code and then just open it back up another class and not necessarily be on the same computer, which is important because a lot of our kids don't even have a computer at home, or they're transitioning to different computers. And so that's actually how we kind of avoided that problem, because it is a challenge.
It is neat. And I know that even the IT departments at school districts, they have to deal with IP and doing things over server if they have Chromebooks, but you're kind of bypassing this. Then, Well,
and also with Chromebooks, you can't download anything.
Exactly, right.
And so that was another thing we had to work through.
Okay.
And so if you can run it in the browser, it doesn't matter.
Yeah.
And the other challenge is, say we downloaded it at school, they wouldn't have it at home, and they would have to replicate the process. And I was like, well, that's not going to work really either. So
how's that going then? Does that work well?
it does, yeah. I do think that when you get to higher level programming, like classes and things like that, which is a programming term, I don't think the text editor can run that, or the online application can run that.
Okay.
But at that point, I mean, I'm hoping that by the time we get to that level, we can download
Go
it.
back and
Yeah,
talk about
because
that.
I do think it's important to download Python and be working, and actually doing it like a programmer would do it. But there's a time and place for it. So maybe in our second level or third level, we actually walk through, hey, this is what it would look like to download it. Here's when you have a problem. Here's different commands. Here's how you move through folders, things like that.
So for an adult teacher who may not know how to code in Python or set up Python,
Yes.
would you recommend a similar method? Learn how to code in Python first before getting bogged down and installing the environment? Or
Yeah, I think for teachers, it's a little easier. I mean, I have found that it can be overwhelming. Like there's so many pieces to it, and, having to download it and figure out like what version of Python do I download and where is that and what does that look like?
it's more complicated than installing Arduino is what I've realized. Yeah.
And if you don't have someone to ask, and then you start looking things up online and you're like, I don't know what to do. And then you just kind of stop. So I would say to start with an editor that's online first. However, there are a lot of free tools out there that will walk you through it. So if you do want to do that, there are a lot.
What are some good resources that people can look for or that you use in your program?
So Learn Python the Hard Way is amazing.
It sounds already intimidating. I've never seen it.
Okay. So it was free up until I want to say a month or two ago, but you can buy forever. You have it. I think it's like $10, and it walks you through lesson by lesson, really spelled out. And he pushes you and challenges you to like try different projects. He walks you through how to download Python, which version to do. You can even email him.
Is this like an online class?
Yes.
Okay.
It's not even a class. It's just self-learning. So like lesson 1 is print statements, and you walk through it, and then he has you write out code and see what it does. Code Academy is good. It just depends on how much time you're willing to give to it. But I think if you give 5 or 10 hours a week, you can get pretty far over time. Yeah.
One of the biggest challenges that teachers face in engineering, in computer science, in every subject is differentiation. When kids come into class at different starting levels.
Yes.
And you were saying that you teach kids that kind of have different starting levels of computer science. How do you deal with that?
Yeah. So what we do is we have about 2 teachers in every classroom, depending on the number of kids. And the reason being is we want to have a good teacher-student ratio, because we do have those students that are really advanced, or it takes a little bit of time to get whatever concept we're teaching. And so one teacher will be up front, walking through a lesson or discussing something with the class. And then another teacher will be walking around, chatting with kids, helping them catch up or challenging them. So we'll have in our lesson plans, we incorporate challenges for kids. So like, okay, so-and-so is really far ahead. Yeah. We're going to see, can they figure this piece out? And so that kind of allows us to reach that range of kids.
Okay.
Yeah, because we see that a lot.
I'm also thinking about marketing, essentially. There's 2 levels of marketing I'm thinking of. One is there's that question of how do you get kids interested in your program or in coding in the first place?
Yes.
And the second level is you've already got these kids. How do you keep them engaged in a text-based programming course? So those are 2 questions. Maybe we'll tackle the first one. How do you get kids, or parents in this case, or their teachers, interested in doing an after-school program or an in-school program like this?
So we get a different types of kids that come in. So we get the kid that has been doing Scratch, code.org, or even has like dabbled a little bit in actually programming, and their parent and the kid are looking for something new and they're like, okay, I'm ready to move on, don't really know what to do. And so they come to us and say, hey, can you help us, learn to actually write code? So we get that group of kids, but then we get a group of kids where their parents just know they're really smart and they're really driven and they're really excited, but maybe sports aren't for them, or, they just want something new for their kid. And so they put them in our program, and the kids usually warm up to it really quickly because it's challenging for them. I mean, programming is problem solving and it's logic. And so kids that are like that just really get it. So they might not have thought they would like it, but they end up really gravitating towards it.
So you're looking for problem solvers or kids who really would like or benefit from problem solving? But
then we also have kids that are really creative. Like over the summer, we worked with a group of kids and all of them wanted to just create these stories with programming, which was really cool to see.
What does that mean? How would that turn out?
Like they wanted to use print statements to talk about unicorns and this cupcake story, and it was great though. I'm like,
I want to read that story.
Yeah, if that's what you want to code, that's fine. We in our classes we talk a lot about how coding is just, I don't use this word, but a vehicle for them to pursue their passion. So, if you're interested in dance or you're interested in volunteering with animals, use coding as a way to further that interest. It's just a tool. It's not the end. It's just the way to get to where you want to be.
You're kind of answering the second part of that question that I posed. How do you keep kids engaged in the curriculum once you've already got them in the seats?
So what I like to say is that games, like gamification, so making, programming really exciting, where you have, like Scratch, that's what Scratch is, right? So it's taking a character and using code to have them move. That's gamification. And that is really great to get kids interested. But at the end of the day, to move from that to being a developer, you have to find a middle ground. And so I think that's what we are. We basically say, okay, we know how to connect with middle schoolers. We know how to make programming relevant for them. And so us as teachers are going to connect with them and get them excited and do fun activities in class. But at the end of the day, we're actually coding. So they're writing lines of code in class and doing projects that are exciting to them so that they'll want to continue. So it's kind of bridging the gap and targeting that specific audience. Does that make sense?
I think so. Because it sounds like you're saying that you don't want to just give a cartoon reward or something every time they learn a concept.
Right. Because, I mean,
that doesn't happen in Google, I'm sure, not all the time.
Right.
Maybe sometimes, but
maybe there, yeah.
Yeah.
I mean, it's not the real world, and I don't want to be a reality check for them and be like, "Oh, hey guys, this
get back to the hole or something." But
okay, I want it to be fun for them, but I still want to show them that you can code and do really cool things with just the code. Like coding itself is really cool. And so we incorporate activities in class to make it fun for them. And our teachers are really fun too. And I think that adds a huge piece of it.
Yeah, your staff is probably a big resource for your team.
Yeah, and they do it professionally. Like,
right.
I learned programming after college and taught myself. We have two teachers that are, like, most of our teachers are actually women, which I love.
Is that intentional?
It's not. But, I mean, I think it's really important to have... a man and a woman teacher is important because the kids will look to them as role models. Yeah. But a lot of our teachers have really interesting careers. One of them was a game developer. Like, she created video games. Another is, she taught herself way later in her career and completely pivoted, which I think is great. And I think kids should hear about that.
Okay.
Yeah. So
you're relying on people and personality and not just gamification and those types of things. Is gamification a gimmick?
I don't think it's necessarily a gimmick. I think there's the right time and place for it.
There is value for it.
There is. Scratch and code.org have been monumental in getting kids to code. I've heard so many great stories of kids that started there and moved on to be programmers. And a lot of our kids started there too. But then they need something else, right? They need a next step from there. What is the next step after Python? If a teacher
teaches Python, what would the student have to learn next? Do you just let them do whatever they want?
So you mean in class? In classes?
Yeah, in classes. Or like when a student graduates, let's say, from your program or finishes it, how do you connect them to the next thing?
Yeah, so, we have different levels of Python, and we like to say that there are, 5 or 6 core pieces of Python that we teach, and we don't cover all of them in the first semester. So that's the first piece. We usually dive deeper, but then we talk about how, we've learned the 5 or 6 key pieces of Python, but then the hard part is actually figuring out how they work together and how to use them as tools to build what you want. And so as we move forward, we challenge kids with projects that are harder and seeing, okay, well, how can you make this program more efficient? Because there are so many ways to create a program. It's just, can you do it in the best way possible? And so that's the part I really like, is saying like, well, I don't know if that's the best way to do it. What do you think? And giving them the freedom to figure that out on their own.
So you could just keep on making it more advanced.
Yeah.
All right.
And I think having them work together on projects is really exciting too, because that's how, programming works in real life. Each person is responsible for different pieces of code or interacting in, code together. And so I think that's cool as well.
What other challenges do you face, or do you think you'll face in running this program?
I think one of the things that I just think in general is a challenge is schools, they want to bring programming into their school, into their curriculum, or even after school, but it can be expensive. It is hard to find quality teachers because with programming teachers, they have to be teachers, educators, good communicators, but they also have to know programming. Yeah. And that overlap is pretty hard to find because it's basically saying, hey, you have to want to work with kids. You're probably going to take a massive pay cut. And that's hard to find. And so, and schools recognize that. And so how do they navigate that? And they also have a lot of pressure from districts for testing. I mean, there's so many pieces that are higher priority. And so
do you think that's why more schools don't do what Kiwi Compute does just in the school itself?
I have seen a lot of high schools incorporating it, which is great. I see a lot more of AP computer science or a computer class where they touch on coding. So I'm seeing it more at the high school level. But I think in middle school, there's too many other factors that they have to, testing or cost. So I think they're aware that they need to be bringing it in, but it's how do they do that? So figuring out how to solve that problem and overcome these barriers. The nice thing is that for Kiwi, we ask our teachers to come for, 2 to 5 hours a week. And so they're actually able to manage a job, full-time or part-time, while still teaching with Kiwi. So it allows them some balance. So a lot of our teachers, all of our teachers have full-time jobs in, software development of some kind.
And they're a part-time teacher.
Exactly. And so, which I think is great because then they can bring that experience to their Kiwi classes and talk about that. But to have a full-time teacher come in, say we were at a school and we had a teacher come in 40 hours a week, they can't work elsewhere. Mm-hmm. And so then that poses a challenge. And I know most schools I've talked to, that is the biggest challenge. Most schools I found that have programming in their middle school or high school, it's a teacher that was a teacher first. Typically, not always. I don't want to say always, but a teacher first that then learned programming and then went to their school and said, hey, we should teach this.
Does Kiwi Compute train teachers to do that, or that's not what you do?
So I would like to. We've talked about, I was telling you about this, we talked about creating an application where teachers could use it and potentially get in front, have more teachers be comfortable teaching Python in their classes, because I totally get it. It's overwhelming. Like, where do you start? What do you teach? Which language is best? How do you teach middle schoolers? You have to have a good understanding of the concepts before you can even teach it. And so if there's a way that we can make that easier for teachers, I'd love to get there. Yeah. It's like a huge goal of mine.
Plus, I like your hint about that business model of getting part-time teachers and letting them do other things, because I know someone else who's in that boat where they teach part-time engineering and then they have their other job as well, and it seems like that's much more satisfying for this person. So
right, because I've met a lot of programmers that want to teach kids. It's just not what they want to do full-time. You know, like they want to teach, they love it, they're excited about it, and they either had a mentor growing up that did that for them and they want to give back, or they wish they had a mentor. It's like two ends of the spectrum. Yeah. So they want to be that person for someone else. They
want to give back.
Yeah. And that's actually how Kiwi started. Marty and I, my co-founder and I, both did not learn in college. We both self-taught ourselves after college, and it really resonated with us. And so we're like, we want to give that opportunity to every kid. Yeah. So.
Well, that's neat.
Yeah. It's been great.
Do you worry about if in the ideal future all schools do teach coding in middle school? Is Kiwi Compute going to be out of business if that happens?
I don't worry about it. That's my goal.
That's your
actually.
Dream goal?
Yeah.
Okay,
so if
cool.
we get to that point, I mean, I'd be happy. I would just pivot to something else, because that would be, I mean, that's what we're working towards, right? So like the more companies that do this, the better, because then every kid will have a chance to code. So I'm totally fine with that. I don't care. I'd be happy if that were the case. Yeah.
Maybe you can teach everyone how to do another programming language that nobody knows about.
Or there's some new career that hasn't even come
it hasn't
up
been
yet.
Invented yet.
Yeah, exactly. And
artificial intelligence or something.
Yeah.
How do people find out more about you and about Kiwi Compute?
Yeah, so I always love getting coffee with anyone. So if you ever want to learn more, you can always just email me. So at julia@kiwicompute.com. I love hearing people's thoughts, feedback, just talking about it.
We're in a coffee shop right now listening to strange background music.
But that, or you can also go to our website, kiwicompute.com. We're always looking for partners too. So if you're a school or nonprofits. I love working with nonprofits. It's like that's my jam.
Yeah. What does that mean? Like you would teach at the nonprofit or?
Yeah. So we go to their program and partner with them. I think that's the best because they know their kids best, right? And so we will go to them and we pick a group of kids that we'll work with for, 10 to 16 weeks and work with them once a week and teach them Python.
Okay. You become part of whatever camp or whatever it is that they're already doing. Okay, that's neat.
Yeah, so we're like a portion of their
I see.
program.
And for a school, you're usually an after-school program, or?
Yes, we've also done during the day.
Okay.
So we'll be part of an elective or something where kids can have a taste of programming through us. Yeah.
All right, well, thanks for those details. And so, Julia, I appreciate all those tips and tricks about teaching Python and CS in general to kids. I'm sure there's lots more we could talk about.
Always.
Yeah, so I hope to have you on again sometime.
Awesome. Yeah, thanks so much. This was great.
Thanks. Thanks again to Julia Lamorelle of Kiwi Compute for speaking. Since recording our conversation, Kiwi Compute had some really good news. They went on to win a business pitch competition from the city of Austin called the Gigatex App Competition. For that app Julia talked about, where people could code in Python over a web browser. As part of their prize, Kiwi Compute will receive $19,000 to help develop that app further. For notes and links related to this episode, including on Kiwi Compute's public Python coding app, you can visit this podcast's website, k12engineering.net. There, you can also find transcripts for episodes. And to help me out, please leave a rating and review of this podcast on iTunes or Stitcher. Follow the Facebook page and Twitter handle. Finally, you can financially support this show by donating on Patreon at www.patreon.com/Pios Labs. That's patreon.com/PIOSLABS. Our closing music is called Katana by Miros, and you can find more music by Miros on SoundCloud under the username Miros Sound, or just check the show notes for a link. The K-12 Engineering Education Podcast is a production of my independent studio, Pios Labs. Thanks for listening. Howdy, it is Pius, and I have 3 post-show updates today. I know there weren't updates for a little while, and it was lacking, but now I got them. One is related to South by Southwest EDU. So as you already heard, if you've been listening to other episodes, I am going to be official press for South by Southwest EDU in March in 2018, barring any extenuating circumstances. I'll knock on wood. But I should be there. And we're going to get news real soon on if our submissions to present are accepted or not. And so I can send you some news. Stay tuned on Twitter, on Facebook, or just listen to the next episode to figure out if we got accepted or not and what we're going to do there. The second update I want to tell you about is that I am working on a programming project. So I actually teach adults some basic math to help them get their high school equivalency diplomas. And so as part of that, I wanted to create a tool for them and for other students to help them visualize number operations, like not just adding, subtraction, but also multiplying and division, squaring, that kind of thing, negative numbers. Because oftentimes, yeah, you can memorize your times tables and whatever, but it might be hard to think about what those operations really mean to physical things. And I like using the analogy to money and debt and profit and stuff all the time. But there's more than that monetary way of thinking about numbers. So I'm hopefully going to create a tool to help people visualize positive and negative numbers and the operations on them soon. And I want to share it with listeners, Patreon supporters, all that kind of stuff. And so listen in if you want to be updated on that. The third update I want to tell you about is I recently looked up how to live stream over on Twitch and a little bit on YouTube and other platforms, but I've joined Twitch. It's that service that a lot of people use to stream gaming and video games live, but there's a trend for coders and programmers to show off their programming live, especially if they are doing open source projects. And so I'm thinking about doing that as well, just for my own learning. But also, when I create games and web apps and tools, I plan to demo them on Twitch as well as on YouTube and other sources. And if you're a teacher, maybe you might consider doing some videos on Twitch. I think it's a cool idea. But that's all I wanted to tell you. I'm thinking about all these things. And please tune in next time.